I guess that my screen is visible. So my paper title is Improved Ransomware Detection and Classification Using Machine Learning and Deep Learning. And I myself am Swati Mitran, and the co-author is Dr. T R Reshmi. And we are from Society for Electronic Transactions and Security Office. So introduction. So what is a ransomware? So ransomware is a type of a malware that prevents the access to the system files until a ransom is paid. Ransomware appears to be one of the so it is one of the most harmful type of a malware which is currently available, and it is infecting most of the enterprises worldwide, and 51% of the enterprises was attacked by ransomware in 2022, and healthcare and financial services are the most targeted sectors by the ransomware groups, because these groups have sensitive information with them of the users, and if those informations are not accessible to them, then there is a high chance that they will be paying to them. So that's why they are targeting mostly on healthcare and financial services, and nowadays it's also they are also targeting on critical infrastructure like the power grids. Once they get targeted, then the whole electricity can be shut down in a city, like in what happened in Mumbai. Also, that was also an attack. In the global scenario, we have a National Health Service of England that has paid around 100 million in damage because of a WannaCry ransomware assault. And there has been like a year by year increase in the amount of attacks which is being done by the ransomware groups, and we need to reduce this somehow. Due to the cyber attack, the largest school in New Mexico, the name is not published anywhere. They have to completely shut their systems out of its vital student information. And this happened in last year in Jan 13. In Indian scenario, everyone are aware of the AIMS ransomware attack, which happened a few months back. That's on December 2022. And 1.3 TB of data was encrypted and 5 servers were affected. And the whole AIMS network was down for the next 2 weeks. And after that, they restored it using a backup server from the backup servers. Similarly, we have a national critical information report on the Jawaharlal Nehru Port Trust, where the Petar Wrap ransomware has encrypted this, and because of that, the port's movements were affected. So these are some of the Indian scenario and global scenario which has put the ransomware in an. We need to detect the ransomware in these cases. So how ransomware works? There are many types of ransomware. The first one, the crypto ransomwares or encryptors. So they get to your system and they will encrypt the data which is present in the system. They will first read all the files, and they will find which file is more recently used or is being used, is important to the user, and they will encrypt those files, and they will ask for a ransom for that. We have a lockers. They will not encrypt. They will just have access denied to you or the user. So they lock the system. Scareware is like a scam without encrypting or locking. They will just put a display message saying that a ransomware has been attacked, and they will give you a address to pay your money, and that's kind of a scam. And we have a leakware where your all information will be fetched by the ransomware, and they will be put on dark web without even informing you or without any information to the user. And ransomware as a service, I'm unable to code any ransomware as an attacker. So ransomware as a service, using a service, I will get the ransomware and infect all the systems. So these are the types of broad types of ransomwares. Similarly, we have an attack sequence for ransomware. So this is the first step is the distribution of the malicious links. Once the user receives it and opens it, the payload will be downloaded in the machine. This payload will connect to the CNC, because the encryption needs public keys and public. It's a asymmetric encryption which is happening. So it needs the public keys to encrypt the data which is present in the hard disk. So it will connect to a CNC, that's a control server, and it connects to there and gets the public key, and it will encrypt your data. And it will then display a message saying that this much amount of the payment has to be done, and otherwise the data will not be accessible. Once the payment is done, the private key will be sent from the CNC server, and the data will be decrypted. So this is the normal process of how a ransomware works. So currently we have some of the techniques to detect the ransomware. So most of the defensive techniques or the antiviruses which are available at the off the shelf in the industry, they use signature based mechanisms or traffic based anomaly detections. The more problem with this is only known ransomware will have signatures, and most of the ransomwares they update in a day or two, or they just change some of the code inside the ransomware, and the signature changes. So it's very difficult to find the ransomware using a signature based mechanism. Similar, in static analysis, in static analysis, we do a code evaluation of the application before it is getting downloaded, after it is getting downloaded to your system. Some of the tools which are used are like PEID, IDA Pro. These tools are used for deassembling the EXEs. The limitation is similar to how signature-based mechanisms work. This also works only on known ransomware, as where we know the kind of ransom, like which the behavior of the ransomware or the code of the ransomware, and it gives a highly false positive rates, and it also fails to detect obfuscated ransomwares because you won't be able to see the code directly. So it will be very difficult to detect ransomware in the static analysis. Similarly, we have the second format, that's a dynamic analysis. So in dynamic analysis, we run the malicious code in a safe environment. So like Cuckoo Sandbox is a widely used thing, and using the behaviors of like network analysis, we have memory, also we have the file access information. All these informations we try to find out whether the exe is a malicious thing or it's a big thing. So here also the limitation is the exe has to be run in a Cuckoo Sandbox, so it's a slower, and it also requires a memory for the virtual environment or the sandbox. The second is the memory analysis. Memory is also is a type of dynamic analysis itself, but doing a memory analysis will give you more details about the behavior of the ransomware. So some of the tools which are used is again volatility, pin, Valgrind, and all these types of tools are used. Limitation is that it's time consuming and it's also a costly process because we need to analyze the whole memory. These are some of the techniques which are currently being used. So the proposed method, in our proposed method, we will be using the machine learning and deep learning techniques on this. So for that, we need to collect the data. So for doing a collection of the data, we need to have a guest machine and a host machine environment setup. So on the right side, you are seeing the dataset collection environment where we have a host which runs on a Ubuntu, and we have a guest machine which runs on a virtual machine, and it runs with a Windows system. So this is a Cuckoo Sandbox is installed on the host system, and we collected around 100 ransomware samples, and we ran those samples in the Cuckoo Sandbox, and we collected the logs from that. And those logs are converted to a JSON format, and which have details regarding like execution time, metadata. We have different malware behavior signatures, drop files, PE section. This is the most important part of the logs. That's a PE sections of the entropy, network connections. So how it is going to connect to CNC server, or what are the URLs it is going to connect. All these informations are connected from the logs. And on the right side, you are seeing the logs dataset format. So it's in the JSON format. Like in the reports, we have a JSON format also. So all this we converted into a JSON format. In addition to this, we also had a ISOT ransomware dataset, which has already contains logs from 669 ransomware samples, and they also deployed the same process. Like we have a Cuckoo Sandbox, and on which they have run those 669 ransomware samples, and they have given us the data set in this format. So this was all about the dataset collection. On the training phase, we use the supervised machine learning models. So the naive Bayes, SVM, decision tree, XGBoost, and random forest. And on deep learning, we use a plain ANN for detection and classification of ransomware. And for classification, we need different types of ransomware. So we use Cerber, Locky, and Tesla Crypt because we had got most of the logs from these three ransomware. So we on the first go, we wanted to try with these things. And once we collected the logs for all these things, we trained using these machine learning models, and we use sklearn and TensorFlow for implementation of this. So on the result analysis phase, we have accuracy from different classifiers used for the detection of a ransomware. So here you can see that we have the maximum for the random forest. So random forest was able to detect the ransomware with a more accuracy. We also have plotted the precision, recall, and F1 score and support for all the algorithms of machine learning and ANN also. So here we also had collected some of the begin files, and we ran those on the cuckoo, and we collected those information also, which I have not captured in the dataset collection. For those logs also, we compiled with compiled in the dataset itself, and we use the training from these datasets. This is the result analysis for classification for ransomware. If you see here, the ANN is performing better, and we get accuracy of 93.24. And if you see in ANN also, the each and every the classification precision and recall is high as compared to other machine learning techniques. So this is all about the result analysis of classification of a ransomware. So in the conclusion, the training of the different supervised machine learning algorithms and ANN was carried out on the dataset which we created from the logs of ransomware samples. And for best detection model, which we came to a conclusion, is the random forest, which has a 95.54. And on best classification model is the ANN, and is 93.24. And it shows the best result for classification of the ransomware. And moving further future, we can have different deep learning models like RNN, LSTM, bidirectional LSTM, and test the same using the same data set, and we'll be training on those algorithms also. So this is what all about the paper which I have presented. So these are the references, and thank you for listening.
Any question? No, then I have one question. So
Yes.
in Windows, we see controlled folder access that is said that it will help, it will basically save you from ransomware. So how good is it?
Sorry, sir, I didn't get you.
In Windows, controlled folder access is there, which says that it is for protection from ransomware. So how good is it?
So controlled folder access is the access to is only given to the that user who is going to use it, and moreover that controlled access folder will not be accessible to other programs. But the problem is ransomware is pretty much able to deceive it, and it will be able to mimic the user behavior of user of the Windows system. So for example, you are the user, the ransomware will be able to bypass it and use your user user account and access to that folder location. So it is pretty much evident that ransomware will be bypass that also, sir. Moreover, some of the ransomwares are like they will be persistent, like they will be there in the cuckoo sandbox for longer much time, like 3 months, 4 months also, they will not show any behavior. The ransomware they have become so intelligent that even in sandbox environment, they get to know that they are running in a virtualized environment, and they will not show the behavior also. So it has become difficult to run it on a virtual environment and get the correct logs for that also. So we are now doing it on a system itself and collecting the logs. So it's like it has becoming very difficult to identify it, sir.
Okay.
Thank you, sir.
One more follow-up question is there. Just one.
Hello. Yeah, thank you so much for your presentation. You had in your research, you have generated your own logs, used that as your data set, and then conducted your learning on it. I want to know if there are any publicly available ransomware signature data sets or any other form of malware that somebody, as a student, I can use.
Ma'am, in GitHub, you can go to the zoo repository. So it has a whole lot of malwares, and signature is also there, as well as the exe also you can get it, ma'am. So in that repository, you can check in GitHub, the zoo.
Okay, the zoo. Okay, thank you.
It's publicly available, and ISOT will also give you a data set. But the thing is, in ISOT, you need to have from your organization, you need to send a written email that you will be using it for only research purposes. Then only they will be giving you the access.
All right. Thank you. Thank you.